Hello, everyone. Welcome to my talk. And let me just start by apologizing for the fact that the talk has not been rehearsed at all. Spent little time preparing it, so there may be interruptions. There may be pauses. I do know the story that I want to convey to you. I'm totally not sure about what exact words I'm going to use it. So. It's going to be live. If someone's offended, I'm sorry. Right, let's talk about React. Is there anyone here in the room who does not know what React is and what it does? Okay, everyone knows React. That's something. That also means that I'm not forced to give some introductory words on React per se, which is incidentally not going to be the exact topic because we have some further words in the topic of this talk. We're going to talk about React still, but React from a slightly different angle. React not as you know it, probably. Has anyone heard of any of these three technologies here? ClojureScript, reagent, reframe? Okay, several hands up. What's your impression? Is it? Has it been fun to use, or difficult, or different? Yeah, I think that's the word. And different does not necessarily mean worse. It doesn't also necessarily mean better. It's just different. But this peculiar difference might appeal to someone. I know it does appeal to me. Let me start with myself. I'm Janus. I'm a full-stack developer at Tree-based. The main stack that we use for backends is Ruby on Rails. We use all sorts of front-end JavaScript libraries to go with Rails. And that's what I'm doing for the living these days. But I'm also an open source developer, and in my spare time I have some pet projects of mine, which I mostly do in Clojure and ClojureScript these days. Has anyone heard of Clojure? I guess people who heard of ClojureScript heard of Clojure as well. It's a language that's very closely related to ClojureScript, which will be the topic of this talk. But I'm not going to delve into the differences very much. By the way, think of this talk not about some lesson on how to use these technologies that I'm presenting, but more of a experience report. I'm just going to tell you some of the things that I learned while using these technologies and share the impression. If this kindles an interest in anyone, that's great. If not, so be it. About that personal project of mine, because that's the story of me getting into ClojureScript. That only happened this year, even though I've been writing regular Clojure for like 8 years now. It has been on my radar of the languages to explore for some time. But it wasn't until this year that I decided to, oh yeah, but by the way, this is my GitHub page. I decided to rewrite a personal project of mine that I last touched some 5 years ago the UI of that project from CoffeeScript and Backbone, which has kind of organically grown to the point of being not very maintainable, and I didn't really want to reach out for the nightmare that is Marionette.js. So I decided to finally give ClojureScript a try. And React and wrappers are kind of a natural choice for ClojureScript web development for reasons that I'm going to cover shortly. And it really went out pretty smoothly. By the way, the project itself is a search utility for text in Polish that understands Polish grammar and inflection. And that's standalone, so it's an app that runs both a client and server on the same PC. Disguised, I mean, a web app disguised as a desktop app. And this technology stack turned out to work well for this particular kind of app. Yeah, let me tell you about ClojureScript. It's a Clojure, only script. It's a very nice summary that I picked up from a colleague of mine. But just like Clojure, it's a language from the Lisp family of languages, which I mean, Lisp family has been around since 1958 at least, and is still alive and kicking, and it's great to do web development in. Unlike Clojure, ClojureScript is compiled to JavaScript using a compiler that is powered by Google Clojure compiler, which really helps with stuff like dead code elimination and rewrites the code so as to make it reasonably fast and usable and stable in production. It seamlessly integrates with the host platform, which in ClojureScript's case is JavaScript. In the case of regular Clojure, it's Java, and in case of a Clojure CLR, it's CLR or .NET. Like Clojure, ClojureScript has a rich family of data structures that are immutable by default. So think immutable.js. The performance characteristics of these data structures are at least on par with immutable.js these days, and are often faster by a factor of 3 or so. And it's the main appeal to me that Clojure and ClojureScript have is that it's extremely expressive and concise. And by expressive, I mean that my thoughts as I program map to the code very naturally after an initial period of being appalled by the initially foreign-looking syntax. And another thing that's important for the things that we're going to cover today is that it's explicit about state manipulation. Because it's immutable by default, whenever you want to have something that is mutable, you need to be very explicit about it. And we'll see what the benefits of this are. Now, just one slide about syntax of ClojureScript. There's only one rule you need to know, and that's a parenthesized expression with something called func as the first element, and then arg1, arg2, arg3, arg whatever as next element. Calls function named func with arguments arg1, arg2, and arg3. The func can also be one of the special, so-called special forms, which do some other fields, things like calling functions, for example, define functions or if statements, whatever. But this is the general rule. If this is in round parents, look at the first element, that names the function to call. This is how you call JS. You just say JS/ and then name of the JavaScript function and then arguments of the function as usual, and it is called. This is an example of the data structure. It's an immutable vector consisting of 4 elements, 42, 100, a so-called keyword CLJS, and a string WarsawJS. So it's square brackets for a vector, and here we see a map which is in curly braces, and it's kind of a JavaScript object, but it conveys explicitly a notion of mapping keys to values. It's more like a Ruby hash. In this case, mapping the keyword first to 1 and the keyword seconds to 2. And that's really it. I know it may be daunting at first sight, but I'm not going to explain it in much more detail because it's not really about you needing to understand everything. It's just it's for you to get a glimpse of how ClojureScript code looks like. Let's go on. Let's go on to reagent. Reagent is one of the several wrappers for React that ClojureScript has, and for there's some other ones. There's at least 3 other ones. There's which historically has been the first one, and it's in the process of being rewritten. It's Quiescent, which I don't know anything about other than it exists, and nobody's using it. And RAM, which I hear is nice as well, except it's thinner in that it exposes more of the notions inherent to React to the programmer. By the way, for some reason, as I mentioned, ClojureScript and React like each other. There's 4 wrappers for React in ClojureScript, and not a single one I know of Ember or Angular. Now, I'll get to that later. There's a reason for that. The beauty of reagent is that it manages to hide almost all the complexities of React and its API behind this simple API that is basically built around a single abstraction, a reactive atom. I'll talk about that shortly. And it's very functional. Most components can be pure functions that just take data and spit out data. And this has many benefits, which we also cover. But if there is a need, which there rarely is, but there sometimes is, to reach out for the less commonly used React API, you can do it in reagent as well. This is an example of a simple component in reagent. That's the definition of a pure function that takes no argument and just spits out a vector. That's how reagent and ClojureScript in general tends to represent HTML. It's called a hiccup notation because of a Clojure library called hiccup, which introduced this notation. It's also kind of natural for the data structures that Clojure and ClojureScript use, if you think of it. So this little function here produces a simple component that says hello, and it's a function that returns a single vector which has 2 elements, one of them being a div keyword, the other being a vector which has 2 elements, the one being the h1 header 1 keyword, the second one being a string hello WarsawJS. And as I said, it's a pure function, which has the benefit of being easily testable in isolation and runnable in isolation and experimentable in isolation. It's also composable, which we'll see is preserved. I mean, the composability of React components is pretty well preserved by reagent. And there's no JSX here, which is nice. The nice thing about ClojureScript wrappers for React is that they completely sidestep the additional complexity that is JSX. It's pure ClojureScript. It's pure functions. It's pure data. It's as pure as can get. This is how composing components look like. We have one component called called hello, which takes one argument. I mean, it's function taking one argument. And this is how you can pass some configuration to a component. Just pass it as a function argument. And then it's using that argument to provide styling to the hello saying component questions. And here we have a rainbow hellos that just spits out this list comprehension. Think of it as a bracketed expressions with for in Python or whatever. It spits out 7 colored hellos, each one in its own color of the rainbow, or wrapped in a single div. And that's how simple it is for simple cases. Now, the sad thing about life and about writing single-page applications is that the world changes. And that components have state. But before I get to that, I'm going to introduce the notion of an atom that also exists in Clojure, as well as in ClojureScript. An atom is just a stateful container for value. So it's a kind of a box, which we speak about that this is a box that is mutable. Hey, bang bang. This is a explicit marker of mutability of a single stream of values. So this one atom here has the initial value of 42. Now, when we call a swap function on it, that takes a function that takes a current value of an atom and some other optional arguments, and calls that function on that current value and those arguments and produce a new value of the function. So it's 42 plus 10, and it turns out when we dereference, that's another explicit thing here, we dereference the atom to get the value that it holds at any single period in time. That's atoms. Atoms have an additional property in Clojure that they are atomic, as the name suggests, so that changes to an atom from different threads are guaranteed to be isolated and atomic. I think that's the case for ClojureScript as well. But the twist that reagents introduces is the notion of a reactive atom. That's an atom that's defined almost like a regular atom. Like in a regular atom, it holds a single value at any single period of time, but the peculiar thing about it is that whenever it's dereferenced, it causes all components that dereference it to be re-rendered. And that's a very, very, very powerful abstractions, as it turns out. Because all of a sudden, all it takes to implement a changing counter is a reactive atom augmented by a simple counter component that displays a current value of the counter, and that has an input button that upon clicking just calls the swap function on the reactive atom and increments it, and all of a sudden the component is re-rendered whenever this happens. And then because this is just a kind of an atom and it's just another ClojureScript value, you can do all sorts of things with it. For instance, this one here is a global variable, which is not necessarily beautiful, so you can hide it. You can pass around reactive atoms. You can share state held by same atom in multi-components. And also, state can be local to components. Here's an example of a version of a counter that, rather than having a global variable, has instead a local binding, and also demonstrates another feature of reagent, which is that a component function does not need to return the component directly. It can also return an anonymous function, as in here. That's the anonymous function here. That does do the render heavy lifting, but it gives us this additional space here to introduce the local piece of state that we then have a guarantee that no one else around this company uses. So that's how it goes in reagent. And that's really all I wanted to say about it. It's just this single abstraction, reactive atom, and you can really do a lot about it. Now, problem is, it's still the same problem that we have with React, which is that it's just a view layer of the typical applications, which is models and views and controllers or view models, whatever. React and reagents provide only the view part. You have to think very carefully about how to structure the general layout of your application, how to, in the case of reagents, which atoms, reactive atoms holding parts of states are going to be global, which local, how to share them, how to propagate changes to them, how to keep them in sync and when, and so on, so on, so on. It's all the same kinds of problems that we have with React. And Reframe, which is the last library I'm going to talk about today, is a library to solve this issue that takes much the same approach as Redux does in the case of React. But does anyone know about Redux? Most people do, okay. If you don't, just bear in mind that it's like Reframe. Now, it's very similar to Redux, but with a functional twist. And the very nice thing about Reframe is that it has a great README file. Seriously, go read it. I mean it, go read it. It reads, it has a plot which unveils as you read it, and there's moments of suspense, there's twists in the plot, there's astonishing realizations along the way. Go read Reframe's README. I do mean it. And it has a couple of bomb mods in it. It's MVC gym, but not to know it. It erases kind of framework, MVC, say, erases reactive atom component event subscription framework. It's derived data all the way down, because data that's derived from other data flying reactively around a single loop, which I'm going to show presently. And it's very simple. Let's talk about the loop. The thing is here is the app.db, which holds all your state, all the state of the application. That's it. All the state of an application sits in app.db, which can be anything. In the typical reframe projects, it's going to be Raton holding a ClojureScript map, which is going to hold all sorts of keys or holding values that corresponds to all the various parts of the state. And I was astonished to discover that in the case of Smirnov, my pet project, keeping things such like the width of the resizable table in app.db is down to this level of detail, it still works. It still does not introduce additional complexity, and it still keeps the spirit of reframe and Redux, which is to have a single authoritative source of knowledge about the entire state of your app. Now, we have components. Components are basically query app.db via, do I have descriptions here? Yeah. Components query app.db by way of named queries called subscriptions, which produce, which are allowed to access the current state and produce the sub-states or views of the state that a particular component may be interested in. They're also composable, subscriptions may depend on each other. And then they produce hiccup markup, which is the open bracket keyword HTML thing we've seen. And then it's passed to reagents, which produces virtual DOM. For consumption for React, which produces the actual DOM that the browser displays, and then in that DOM there are UI widgets such as buttons and links that can dispatch events, put them on a sort of a conveyor belt, and then the router takes these events on the other end of the conveyor belt and invokes the appropriate handler. And the handlers are the only things in this loop which are allowed to modify this state of the back and merge it back with whatever app.db is currently holding. It's very similar, in my view, to what Redux does, except there's no there's less abstractions. I don't even remember what the Redux ones are. The thing I love about it is that almost everything here is pure functions that take pure data and return pure data. All these things are runnable, testable, composable, and experimentable with in isolation. And it's just functions that take data and produce data, which are then passed to the other functions down in the chain, down in the other layer that take data and return data. And so it's really the right data all the way down. That's Reframe's tagline. And just to conclude, I'll show an example of the counter that we've seen with pure reagents implemented in Reframe. That's the initial state. That's what app.db will be like in the beginning of our app. That's the handler that's going to be called upon initialization of the app, which is going to just take an empty state, which app.db has at the beginning, and a event that we ignore, and just return the initial state. So it's going to be, ignore the empty state and put the initial state, the count 0, in the UpDB. And then while we're at handlers, we have another handler called bump that again takes a current state, and an event that we ignore. The event may contain parameters to the event handler. And then it updates the state to increment the counter. That's what this little line of code here says. And that's it for the event handling part of our contract. The corresponding part to read the state is the subscriptions. That's the part that queries UpDB, asks it for whatever piece of state it's interested in. In that case, it's a count. And wraps it in a thing called reaction, which is like reactive atom, but it's kind of a view. It's another thing that you may dereference, and it produces a value, but that only changes whenever this particular part of the state change. So this is efficient. And by the way, the reason why all these wrappers for reacting ClojureScript are efficient is that everything in ClojureScript is immutable by default, so you almost never need to implement should component update. And 99% of the time, you just write pure functions, taking pure data and returning pure data. What could be beautiful, more beautiful? And the counter, that's a component proper, which creates a subscription to which subscribes to our query for the current count. And it returns an inner function that renders a counter value and a button, which when clicked, dispatches the bump event, this one here, to change the UpDB, and it works. And one final slide about the lessons I learned. React and reagents forces you to think differently of the application you're writing, especially when you're coming from the lookalikes of jQuery and whatever. It's just a totally new way of thinking that you need to adopt. The way you need to forget about manually manipulating the DOM, because that's going to be taken care of for you anyway. So you're going to produce the actual markup that you want in your final DOM, your final HTML. It's different. It takes time to switch to. But I've totally forgot about using should component update. And most of the rest of React API. With the sole exception, in my app there are, say, a couple tens of components, most of them pure functions. One of them is using D3 to display a fancy visualization. That one does need to drill down to pure React API. And to implement should component update, and to implement component did mount, and to implement component will mount, and whatever. But that's the exception that proves the rule. And to reframe, I found making the code maintainable and really pleasant to work with. I mean, I've found myself liking developing UI for my app. That was kind of a refreshing experience. And the UpDB thing might seem scary, but it's not really. I mean, I don't want to say that this application I was showing is huge, because it's still rather small. It does have about 20 elements in the global state. Some of the elements having their own sub-elements. But it still does not invalidate the point of making the code maintainable and fun to work with. And I think I've said everything. Does anyone have questions?
Plenty, I saw. You first.
At a first glance, the subscriptions in Reframe look much like streams.
Yeah, and I mentioned Reframe's README. The README makes this exact point, that they are really streams, and that when you think of it, the AppDB, I mean, the reactive atom that is AppDB also can be thought of a peculiar kind of stream in itself, as a stream of constantly derived data from some previous user interactions with the whole app. Yeah, good observation.
That's very, very nice. Thank you.
Mm-hmm.
Any other questions? Well, you made my mind happy with this technical presentation. I think well, you convinced me, especially with the fact that I'm not going to need to rewrite again should component update. Component should update. Well, this is fantastic, because always when I wrote this line of code, I felt very guilty. So thanks a lot about that. Thank you.